Well, we're going to finish up on oxidation numbers today. I got in a hurry a little bit the other day. I want to make sure that I got this right and make sure that you got it right. Oxygen, the rule for once again, the rules for oxidation numbers. Oxygen is -2, except in peroxides. Remember, peroxides is anything 2O2, so this could be hydrogen peroxide or sodium peroxide or whatever. But if it's a peroxide, we know it's a +2. So once again, so if I have H2O2, then what's the rule? It's +2. And I may have put I don't know, I haven't gone back and checked my other tape, but I may have put a -2 on there. So let's just make sure we know that all the peroxides are +2 for the oxygen, all peroxides. So H2O2, that's +2, so that makes that a -2. If we have K2O2, same rule, +2 and -2. So just want to go back and so once again, I haven't taken a look at that past one, but I may have put a -2 on there. So just make sure you got those right in your notes. Okay, here we go. Now, so we learned all of that to learn this. Okay, we learned all about oxidation numbers to get to what chemists need to know. Okay. This is what chemists need to know. Chemists need to know, I take a chemical equation, I pull something out of the air, I find something that's going on, okay? All right? Now, here's a chemical equation, okay? All right? Magnesium, okay, plus Cl2, okay? 2 atoms of chlorine, all right, yield MgCl2. Well, it's balanced, that's all good, okay? That's all good, but what we want to know now is we want to know something about, is it a redox reaction? Now, what do we mean by redox? Okay? Well, oxidation, when we talk about oxidation numbers, okay, oxidation is an increase in oxidation number. We can put oxidation number to help you there. Increase in oxidation number or a loss of electrons. Okay? Because when something is oxidized, when something is oxidized, it loses electrons. You know, what happens when something is, rust is oxidation. What happens when it loses electrons? It breaks down, okay? So oxidation is an increase in oxidation number, okay, or loss in number of electrons. Reduction, okay, is a decrease in oxidation or a gain of electrons, okay? So if something is oxidized, okay, if something is oxidized, okay, all right, so if something is oxidized, if it's a loss of electrons, that makes it a plus charge. Okay, because loss of electrons means less negative charges, more plus charges, because of the balance between the protons and the electrons. Okay, so when we say oxidation, it's a plus. Okay, now when we talk about reduction, okay, we talk about reduction. All right, it's a decrease in oxidation number or a gain of electrons. So what do we mean by a gain of electrons? It's going to be more negative. It's going to be more negative. Okay, so got to understand that oxidation. Okay, increase in oxidation number, loss of electrons, more positive. Oxidation, more positive. Okay, reduction, more negative. All right, here we go. Everybody follow. So redox reaction means that something is reduced and something is oxidized. For it to be a redox reaction, you have to have one of each. So let's look at this reaction. Now let's say to ourselves, first of all, is it a redox reaction? So what is the oxidation number for magnesium? Okay, well, let's see. Now, remember I told you rule number 1, but I said, hey, this is the one you're going to forget. It doesn't have hydrogen. It doesn't have oxygen. Okay? As a matter of fact, it's one element by itself, but it doesn't say it's an ion. Okay? But what do we have here? Oxidation of an atom in an uncombined state is 0. Okay? So that's 0. Now, we got another deal. So the oxidation number for magnesium there is 0. Now, here's why I gave you this example. I want to give you something with Cl2. All right. Even though chlorine is combined with itself, it's still chlorine. So the oxidation number is 0. to be combined with something, we have to make a molecule. Okay, besides a diatomic molecule, all right, we have to make a molecule. So magnesium is 0, chlorine is 0. See why I wanted to show you that? Because I thought when you got on your test, you saw this 2, you'd be like, now wait a minute, I don't know, does that mean chlorine is combined with chlorine? And how would I solve that? Well, that'd be a real problem, wouldn't it? That would be a real problem because where would we go with that? I mean, it's 0, so it fits rule number 1, but it doesn't have a hydrogen, doesn't have an oxygen. So rule number 3 says it's the most electronegative. Well, we only have 1 to compare. So is it the most electronegative? Well, there's only 1 there. So the oxidation number is 0. Okay. So here's our reactants, yields our products. So now I've got to do the oxidation number for magnesium dichloride. Okay? So now what am I going to do? Well, I'm going to say to myself, okay, I'm going to look at my rules. Okay, well, I definitely have a compound, so it's not something I can combine. It doesn't have hydrogen. It doesn't have oxygen, so it's going to what? It's going to electronegativity. So once again, remember, electronegativity goes up and over. So let's look at magnesium. Well, it's relatively easy, okay? Here's magnesium right up here at number 12, all right? And here's chlorine all the way at number 17. So it's pretty obvious that the most electronegative is chlorine, okay? So what's the rule, okay? The most electronegative is -1. That's pretty easy to remember because electronegative, the key word negative there, so that's a -1. So here we go. So what does that make magnesium? So what does that make magnesium? Well, it makes magnesium what? Because -1, but there's 2 of them, so it makes it a +2. Okay, everybody good so far? So really we took our reaction, we did the oxidation numbers. So now my question to you, ladies and gentlemen, members of the jury, is this a redox reaction? Okay, so what do we mean here? Okay, well, let's look at magnesium. What did magnesium do? Magnesium went Mg0 over here to Mg +2, all right, in the reaction. Okay, we still have the Cl2 minus 1. So what happened here? Did we have? So it's redox. It's definitely redox here. But what do we have from 0 to +2? Here's my question. Okay, all right. Did we lose electrons? Did it become more plus or more minus? Well, it became more plus because it went from 0 to +2. So this is my oxidation. Oh, I have oxidation. Now, do I have reduction? Well, let's see this, okay? So my chlorine, okay, here we go. So my chlorine, okay, the chlorine 2 had a 0 charge. What did it go to? It went to a Cl2 minus 1, okay? So did it go to more negative? Yes, now I have more negative, so there's my reduction. So is it a redox? And the answer is yes. Yes, it's a redox. Oh, because one got to be more positive and one got to be more negative. Right? One got to be more positive and one got to be more negative. Now, is this a redox? And the answer is yes. So now we say, now it gets pretty easy. Now that we understand it, now this is what we need to know as a chemist, because I got to know which element's oxidized, because that element's going to start, once again, what's oxidized? It's going to lose electrons, right? So I got to know what up in the sky up here, what up in the, or let's just take, this is kind of cool, okay? I'm going to show you why I gave you this problem here in a minute, okay? I'm going to show you why I gave you this problem in a minute. This problem's a really big issue in water tanks. It's a really big issue when we chlorinate your water at whatever city you're at, okay? So what happens is, we say yes, it's a redox. Now, here's question number 2, and you'll be given different chemical equations in a couple different tests. You'll be asked this a couple different times. Your final exam will have one of these. It'll be a different chemical equation, and you'll have to figure oxidation numbers, and then you have to come back and answer these questions. Which element is oxidized? What does oxidized means? Plus. You know, I don't know how you remember it, but I think if I'm pushing against an ox, a big old ox, I'm going to have to go plus. I'm going to push it extra hard, extra hard. And reduction, I can always remember reduction because reduction means reduce, which is a minus. But which element is oxidized? One became more plus. Well, which one became more plus? Magnesium. Mg. Okay, why? Because it went from 0 to +2. Which element became reduced? Reduced means it became more negative. Well, it was, and in this case, we just put which element? Chlorine. Okay? Because it went from 0 to -1. Oh. Okay? Now, then we're going to turn around, we're going to ask you a real simple question that sounds hard, but it's pretty easy because we're just going to reverse them. Which substance is the oxidizing agent? The agent is the one that makes that one do that. Okay? So the oxidizing agent is not the one that's oxidized, it's the reducing agent that made it be oxidized, so we reverse them. Which substance is the oxidizing agent? Chlorine. What did chlorine do? Chlorine made magnesium become more oxidized. Which substance is a reducing agent? That would be magnesium. Magnesium made chlorine. See, once again, agent. The agent is the chemical process that causes the other to respond the way it did. Okay? So which substance is the oxidizing agent? It's chlorine. What did chlorine do? Chlorine made magnesium become oxidized. What does oxidized mean? Become more plus. What substance is a reducing agent? It's magnesium, because magnesium made chlorine become more reduced. What does that mean? Made it more minus. Now, you may have to watch this 2 or 3 times. I'm telling you, and I mentioned this earlier when we started these videos about 2 or 3 videos ago. When I first saw this, and I sat in college and I watched this, I was kind of lost. So we've tried to simplify. We're going to spread this out into several videos to try to get you to see this. So that's what we're looking at there. I want to tell you real quick, really interesting, because as a chemist, this happens in your water supply for your cities. So why would I even need to know this? Okay, why would I even need to know this? I need to know this because magnesium, anything that's chlorinated, okay, anything that's chlorinated, chlorine becomes the negative, which is reduction. So anything that's chlorinated, let's look at this. Wow. Any element that's in your water, other than the hydrogen and the oxygen, H2O, you have magnesium in your water, you have sulfur in your water. Anything that's in your water, look at this. This is really fascinating, okay? Anything that's in your water, when we chlorinate it to kill all the bacteria and get everything out, what are we going to do? We're going to make it -1. But anything that's in your water is going to become +2. So I am going to have what? Extra ions. So when I chlorinate that water, okay, let's think about this, and my chlorine comes out of my water, then I'm going to begin to get what's plus? I'm going to begin to get some oxidized agents in there. I'm going to get oxidation. So what am I going to get? I'm going to get these, if I take this water and I let it dry out, I'm going to get this little layer, I'm going to get this little film of magnesium and sulfur and everything that's in the water. And you're like, well, why did it settle out? Why did I get that quote-unquote lime in there? Because of the chlorination causes me to be able, it's going to cause everything in there to be a +2 charge. Now, that's not an important thing for your test, but I want you to know that tells me a lot about your water supply, just based on what we just did. So just trying to give you an application. We're going to call it quits right there, and I think we're going to, I think you're semi-expert on oxidation numbers. The more you watch it, I think the better you'll get, but practice lots of problems. Practice problems with this. Change the chemical reaction a little bit. Just be sure it's balanced. Okay, you can use any kind of reaction you want, and then practice see if it's a redox reaction, oxidation, and reduction. So, good job, tough information. We're getting into some serious chemistry here. It's pretty real stuff, isn't it? But you guys are hanging in there doing good. See you next video.